recording. Yeah. See, I completely understand. Okay. This material contains many things. Okay. So right now, I mean, the assignments or the exams are there s- only there so that you can connect some of the theory portion to practical. Okay. Or so that you can just think on those lines. Because if you read the theory, it is just an information that is going into your head. But when you try to solve the assignments, you actually can think. So the whole point of assignments or the whole point of questions is that. So do not get worried if you are still not able to understand some concepts. These, as I was telling yesterday also, these courses are there only to give you the push in the right direction. Okay, after that you have to self drive. Okay, so just make sure whatever, see this NPTEL certificate or NPTEL question answers, I mean, it really doesn't matter if you score 90, 95 and then you forget. Okay? There is no point of doing all these courses. But the point, even if you score 70, but at least if you are able to carry this forward, it will really make sense in your life, and that would be the the goal of NPTEL, and that is the goal of NPTEL. NPTEL is not only for exams. So I also tell this. I mean, I am also a student, so I do understand when in ISC. So these are all for These are all information center. The knowledge is actually in your head. Okay, how you connect the information and how you develop your own framework. So knowledge is very unique to yourself. But then information you can get from anywhere. So NPTEL is also an information center. So treat it like that and carry forward. I mean, these embedded systems are there in this world. Okay, for a very very long time. It was there and it will be there. It is not going to die off very soon. So better you start working on embedded systems, because it will definitely get, if you want a career on embedded system, it will definitely get you a career. If you want to do a startup, if you want to do a freelancing, embedded system is something that is there all over. Okay, if I talk about FPGA, it is very very specific, so it might not be there everywhere. But embedded systems, microcontrollers, it is something that you must know. Okay, it has become English of in all this engineering world. As we need English for communication in education world, similarly it has become the English of engineering world. So you should know embedded systems, so treat it like that. Okay, and don't worry about the exams. You all will do well, and it does not matter whether you get 70, 75, and try to come out of that marks. Okay, but just tell me whether this marks get added up in your final BTech exam, or these are just like courses we are doing side by side.
I think credits are given. I guess
Okay.
because I passed also. I don't know.
Acha. Okay. So yeah. So I think. Hmm. So good. Since people are less here, I can talk to them personally. Ankita, are you there?
Yes, sir.
Yeah. So what I mean, what you are doing? BTech.
Yes, sir. Final year BTech, seventh
Okay.
semester.
Okay. And what is your discipline?
Electronics and communications, sir.
Okay. Okay. So how did you like the course? Do you have any questions?
Um, no, sir. Actually, like it's more of application based. So I was trying to. I have an Arduino board, so whatever was
Hmm.
taught, I was actually doing it like with all the sensors and everything.
Correct.
It's
Correct.
just that the STM one, I couldn't.
That's
Uh,
okay. Arduino is
prac-
also
uh,
fine. Arduino is also fine.
yes, sir.
Okay. So yeah. Venkata, Lakshmi.
Sir, I am working as an associate professor
Okay,
in
okay,
BAP College in Andhra Pradesh.
okay, okay. Then I should call you ma'am. Hello, ma'am.
Okay, sir. Thanks, sir.
Yeah.
And actually, our syllabus is only up to the microcontroller 8051, sir.
Okay,
So
okay.
we are trying to modify that in future to include the ARM
Hmm.
microcontroller.
Hmm. Hmm.
Many colleagues are not coming forward to change the syllabus. That means whether the students can grasp the new things or not, that is a doubt, sir.
Hmm. Hmm. Hmm.
we can give the better concepts with the simple microcontrollers, no, sir. So that's why we are not changing the syllabus.
Correct, 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 correct. So just whenever you teach to your students, just make sure that you give them demo examples. Okay.
Okay.
In online platform, it becomes difficult to give some demo examples, but just try. That would be very nice. Okay. Then students actually normally get a feel. See, what I have understood is because of this YouTube and all, we have stopped visualizing. Okay, because most of the things are there in front of our eyes, and it is visualized. I mean, it is already given in a presentation form. So, but normally the way we should actually study is, let's say, that will increase our visualization power. That if we study from book and then we try to imagine. Okay, right now the imagination is there in the form of video in YouTube. So that's why most of the people right now do not visualize. Okay, but it is very important that people should visualize. Whatever they study, they should try to connect and visualize. It is very important, or else, I mean, this in the long run, no, it will affect. So I always try to do that. It is not that I do not watch YouTube, but I do watch YouTube, but I mean for many of the concepts, but then uh, don't be dependent on that. Okay, so that would be very nice.
Yes.
And if you give some demo examples in your class, it would be really good for the students. So,
Yes, sir. So the last 2 weeks, material is including so many number of interfacing experiments.
hmm,
We got very good idea,
hmm,
and need some amount of small communication gap is there. In the sense, it
hmm,
available, and we are able to see the only main program, sir.
hmm,
I see what is missing. I have to execute the program, sir.
hmm, 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 hmm,
Uh, in 2 days back, I have executed only one program. I
hmm,
said with that one. Later, I will do the remaining.
hmm, hmm.
Then,
Okay, thank you, thank you. Arun, are you there?
Yes.
Hi, hi, yeah. So,
Hello.
what you are doing right now? I mean, are you working or
Yeah,
studying?
I'm working in a college office.
Okay, okay, great, great, great. So, I mean, any questions you have first of all in the whole slides or in the courses? Because if you have any questions, that is priority. I'll try to answer them.
I haven't gone deeply through all this.
Okay.
I have a little time for
Hmm.
preparing,
Hmm. Hmm.
as it is admissions are going on.
Okay. Okay. But then, how is your preparation for the exam?
I just am working on the assignments,
Hmm.
past
Hmm.
assignments.
Hmm. 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 Okay. Okay. Fine. Parikshit, I think we had an interaction yesterday, right? Yeah.
Yes.
Do you have any further questions on the slides or something?
Actually, I want to know how important is data structures
Well, data.
from the point of view of embedded systems.
See, yeah, data structure is important, considering only the linked list part, and then the maybe see
The
trees.
stack.
Yeah, stack. They are all like uh, their stack is like last in first out, right? So the last to be
Yes.
in, the first to be out. So see, I would suggest from the data structures you study only linked list. Okay, if you study linked list and doubly linked list, that covers almost everything.
Okay.
Okay, I think linked list is something. I mean, that is the basis of data structure. So if you study linked list properly, you can apply those concepts to anything.
Okay.
For
Yesterday I asked you about machine learning.
hmm, hmm.
So I was thinking the data structure is important from that point of view.
No, no, data structure is not important from machine learning point of view. No, it is not. Okay.
Only the C++ programming.
Yeah, C++. I mean, see, for machine learning, I would say programming is not at all important. Okay, what is important is the statistics part. I mean, that is important.
Oh,
If you say
right.
what is the crux, then I would say the statistics is important. Then
Okay.
C, C++ programming or Python programming, that all comes after that. So, I mean, once you optimize your model very well, then you don't have to worry about programming. Okay. So, I don't think, I mean, data structure as such is not very much important from the ML point of view, because the more you go into data structures and all, the more memory space you consume, and then the whole things becomes tough. So data
Okay.
structures are not very important from for ML, but yes, the statistics
Okay.
portion is very very important. Okay.
Okay.
Okay,
Thank you.
no problem. Uh, Madhavan,
Hello, sir.
hello, hello, hi. So,
Hi,
what
sir.
are you doing?
I am going final year this week, sir.
Okay, great,
Seventh
great, great.
semester,
What is your discipline?
electronics and communication, sir.
Okay, electronics and commerce.
This
So,
is my second course in NPTEL, sir.
okay, the first course was
Very long.
okay, very long.
Traffic,
Internals
sir.
and acha, okay, okay.
Sir, I cleared that course. This is my second course.
Hmm,
Uh, during my exam, semester exam was going on, so
hmm.
I was little bit slow. But now I completed every week videos and I'm just revising the things, sir.
Okay, just one thing. I mean, whether your NPTEL this exam out marks will it get added to your BTech marks?
Yes, sir. If we apply in university, they will give the credit, sir.
Okay, okay. Hmm.
There is a something rules. I
Okay.
don't know about that, sir.
Hmm.
If we have to go, that means we have to get some credits to
Hmm.
pass the degree, BTech
Hmm.
degree.
Hmm. Hmm. Hmm.
If we kept arrear in some paper in universities, we can
Hmm.
add this credits and we can pass the. Uh,
Oh, okay, okay, okay. That way.
that
Acha.
yes, NPTEL gives 2 credits for
Hmm.
each course.
Hmm.
But I think I will not add. I have cleared all the papers.
That's good. That's good. So, any questions do you have from the course? I mean,
No, sir.
from
I have enrolled this course for my project work.
acha. Okay.
Before this, I was not aware of anything. Like
Hmm.
yes, during COVID time, everything went like
Hmm.
in online and no concentration in studies.
Hmm. Hmm.
So, but I was doing in microprocessors good in
Hmm.
that sense.
Hmm.
Uh, though I got interest in embedded systems.
Hmm. Hmm.
I'm thinking to do a project in ADAS technologies using
Hmm.
some controllers and like that. Sir. So I want to know about embedded systems. So though I put this course,
Hmm.
it was very good, and now I know about every sensor and how to use that, how to
Yeah.
program that.
Yeah. Hmm.
It will use for me, and I'm next semester I will go in advance in
Hmm.
this.
Hmm.
And it
Great.
will also help for my placement, like
Correct. Correct.
in core companies,
Yes.
if we
Yes.
have to go. That's
Correct.
only. Sir.
Correct. Okay. Thank
Thank,
you.
thank you.
Nupur, are you there? Okay. I don't think she is there. Lalita. Okay. I don't think she is there.
Sir, if possible, we need some revision of the architecture and instructions in your way, sir, such that these are important. Like I am not asking important.
Hmm.
See, this is the meaning. This is the meaning like that one. The types of instructions that is there in the material itself. Sir.
Okay. Okay. Then let me check. Yeah.
Yes, sir.
Just hold on. I think it is in week 2, right?
Yes,
Then,
sir.
okay, sir.
Yeah. So I'll share my screen maybe. Yeah. So first of all, see, I'll go through the slides once more. Yeah. So normally in ARM instruction set, you have all this information, right? So there are more. See, ARM is based on load stored architecture, right? So what is the meaning of load stored architecture? If someone can tell me. Hello, are you able to hear me?
It is used to transfer data between memory and registers.
That's okay. But see, the meaning of load stored architecture is that No operation will happen directly on the memory. Okay, it will
All
not.
right.
Okay, so the this thing, all the data from your memory will be first brought to the registers, and then the instructions will operate on those registers. So the instructions operate only on this register part. Okay, just hold on. Yeah. So it will never happen on this program memory or data memory. Now, what is this kind of architecture? Program memory and data memory architecture?
Hardware architecture.
Yes, exactly. Harvard architecture. Okay. So
Sir, can
now,
you brief that von Neumann and Harvard?
yeah, in von Neumann, what happens is, see, right now, what happens whenever you have this ALU, okay, you have the ALU, whatever program you are dumping, no, that comes in this program memory, okay. Now there are some intermediate variables which are getting generated, right? For example, let's say your program says a equals to b plus c. A equals to b plus c plus d into e. Okay. So first it will do is a equals to b plus c. So b plus c will come to the registers, and you will do b and c will come to the registers. You will do a add operation. Then intermediate value you will store in this data memory. Okay. And then you will do d into e, and then finally you retrieve from the data memory, take it and store it back to data memory. Now see, for all these things to happen, the program memory and data memory, we need buses, right? We need some data buses. So the data bus is separate for data memory and program memory for hardware architecture. Okay. So what happens is, when we are fetching an instruction from the program memory, we can parallelly write the intermediate result to the data memory. So that will save some cycles and that will speed up everything. Okay. Which is not possible in von Neumann architecture. Why? Because von Neumann architecture has got one single memory. It is called program and data memory. Okay. And then what happens? I mean, when you fetch the program, you cannot, because the data bus is already in use because you are fetching the program, right? So you cannot parallelly write the intermediate data into memory. What you can do is you first fetch the program, then in the next cycle you might write the intermediate value into the memory. So you need two cycles in von Neumann architecture. But in hardware architecture, everything is, I mean, this transaction is very much parallel. Okay, so that gives you a speed up. Okay, but what is the problem in that hardware architecture? You get the speed up,
Should
but
we need a control circuitry for?
yeah, control circuit is there as a part of ALU. But
Okay.
what extra you need? You need two data buses, right? So the number of lines are more, because program memory will have a separate data bus and data memory will have a separate data bus. So instead of, let's say the data bus is 18, so it will be 18 plus 18, 16. Sorry, 8 plus 8, 16, right? You will need 16 to parallel lines. But in von Neumann, you need only 8 parallel lines. So that is the reason in this modern day architecture, in the DDR, so inside the memory, inside the controller, you have instruction cache and data cache. So that follows a Harvard architecture. Okay. But if you see outside the controller, there is only one data bus, so that the number of pins of the controller does not increase. Okay. So that part you have this von Neumann architecture. So when the moment you get a IC or let's say controller, it will have only one data bus, right? Let's say D0 to D8, D7, and that you connect to memory. So that architecture is von Neumann. But inside that controller, you have cache memory. So cache memory will have instruction cache and data cache. So that part is von Neumann. Okay. So that part is Harvard. So in present day microcontrollers, what happens? You have a mix and match of both Harvard architecture and von Neumann architecture. Is it clear?
Oh, of course, there is control bus, isn't it?
No, control bus is anyways there for von Neumann and Harvard.
Okay.
Control bus is anyways there. Yeah. Yes. So you have, see, the ARM instruction set has got data processing instructions, data transfer instruction, and control flow instructions. Okay. So what is meant by this? Let's say you have written a program, okay, where you want to add, okay, two values. Okay. So what you do first? So first you have to bring those variables from memory to registers. Okay. So that is done by data transfer instructions. Okay. Then after you have brought the values to the registers, you do addition on them. So that is data processing instruction. Okay. Now based on this value, you might want to do, let's say there are some if else condition. Okay. So based on those values of the output, you want to move your control counter or program counter to some other memory location, because if your value is true, you do some operations, else you do some other operations. Okay, so there is a break in the control flow. It is not sequential anymore. Okay, so I mean it is sequential, but there is a if condition. So at that time we have this control flow instruction. So your major ARM instructions majorly can be classified into these three. Okay, I mean, many people are coming, I guess. Yeah, yeah. So first is the data processing instruction. So you tell me one thing. For example, if I have to do only some addition operation, okay, only some addition operation, what will be the sequence of instructions? Anyone?
Read both the inputs
Read both the inputs from where?
from the data memory.
From the and data is present where? In
RAM.
the what? Program memory, right? So
Yeah.
this is the final bin file where you have this data. Okay. So and what kind of instructions we will use to read the data?
Fetch instruction.
That's okay, fetch, but it comes under which category out of these three?
Data transfer.
Control flow.
Correct. No, no. Data
Data
transfer.
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 Correct. Data transfer. Why? Because you are bringing this program memory, whatever bin file you have put, it has been put by the user. Okay. Some instructions and data he has put. Now first you have to read, right? You have to read from here and you have to bring it to the registers, because ARM works on load store architecture. You bring it to the registers. Now use data transfer instructions for that. Now you have to do an addition operation. So what kind of instruction you will use?
Data processing.
Correct, data processing instructions. So right now in the example that I gave, there is no use of control flow instructions. There are only two instructions involved. Correct? Now you tell me that based on, let's say that based on the data that I read and I do some multiplication addition operation, then based if the addition operation is 0, then I do a multiplication operation. If the addition operation is greater than 0, then I do a division operation. Okay. So what kind of instructions will be used here from start? Can you tell me?
Same the data transfer and processing instructions.
Sorry.
Data transfer and data processing instructions.
And why not control flow? I
Because
said like
at one time there is only one operation, isn't
yes,
it?
but I said right that based on the multiplication value, I'll either based on the addition value, I'll either do a multiplication or a division. Correct.
So we need compare instructions.
We need
Compare instructions.
compare instructions, but compare instructions comes under which category?
Control
Control
flow.
flow.
Correct. Control flow. Yes. So based on the compare instruction, what you do is either you jump to multiplication or you jump to division. So whenever this jump portion is coming, it goes to control flow. Okay. So these are the basic three instructions. I mean the basic segmentation of all the instructions. Okay. Now we have this. Now we will come to data processing instructions. Okay. So you see, in these data processing instructions, what happens? These are all add, ADC, sub, SBC. So what is happening here is they are all operating on registers. Means that the data is already present in the register. Okay. So you must have brought all the data from the memory to the registers first. Then only this add instruction is there, because you cannot anyways add them into the memory, right? So you cannot do that. Now what we have is, see, there is also bitwise logical and instructions and all. So these instructions you may have to study in detail. I mean detail means you just know okay, what these instructions are doing, because anyways when you are programming a controller, the instructions will vary from programmer to controller to controller. So you might have to study for other controllers as well. But what is important here is right now you are seeing that all the instructions are between the registers. You are moving that. So here what we have, just move, wait. So register move. This will come under which instruction set?
They all come under
Correct.
data processing.
Why? Tell me.
because they are working on resistors.
Correct. Anything? Anything else? Anyone else who wants to say anything else?
I will say that they are data transfer instances,
Okay,
right?
data transfer. So we will understand what is the meaning of data transfer. See, data transfer instructions clearly says when it is between registers and memory, right? So when you are changing the, when you are bringing the bringing the data from the memory to the registers, or you are putting back the data from the register to your memory, at that time only data transfer instructions are valid. Okay.
See, defined in the ARM instructions like this one, sir. But normally we are in microcontroller we say the
Yes, 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 yes. But it is specific to ARM. This is only specific to ARM.
yes, sir.
Okay. Okay. So someone said that compare instruction is for this control flow. So compare instruction is not, does not come under control flow. The values of the value of the compare instruction, what you are doing with that will decide whether you are going whether you are using control flow instructions or not. For example, this comp R1 R2, okay, so it will set the carry bit, okay, or the CC on R1 R2. So based on the carry bit, if you want to jump into some other location, so that is called as control flow instruction. Okay, jump instructions. Okay, they are control flow instructions. Okay, so these are all acha. So what right now everything is operating in between the registers. Now there is a separate type of, this also comes under data processing, where you are, what you are doing, this 2 is a constant, right? This 2 is a constant. So from where this 2 is coming? Because you are bringing your data from R1 to R2 and all those things, I mean from memory you are doing. So where this 2 is stored?
It should be stored in the data memory.
No. See, understand that whatever intermediate data you are generating, that is stored in the data memory. Okay, whatever your program is generating, that is stored in the data memory. But whatever your program is using at the first, that is always stored in the program memory. Okay, so for example, let's say if I write one program where a equals to b plus 2. Okay, now this instruction along with the value 2 will be stored in program memory. Now after your operation is done, this a value will be stored in data memory. ठीक है? Is it clear?
So if we declare a variable that is a equal to 2,
A equals to 2. Yes.
so where it is stored?
It is stored depends where you are. Is it a global variable?
Oh yes, it is a global variable.
Yeah. So it is stored as constant in, is not in the constant. It's stored in the program memory. Okay.
Okay.
Now let's say you are doing in your control in your whole program, you are doing b equals to a plus 3.
Hmm.
Okay. Then b is stored in your data memory. Okay. And where is this 3 stored? I have just said b equals to a plus 3, right? Where is this 3 stored?
In the program memory.
Correct, correct. It is stored in the program memory. So whatever intermediate values you are generating, okay, which was not a part of your program. See, the value of b variable might be a part of your program, but the value of b was not a part of your program, right? So all these
Right.
intermediate values which are generated, they are all stored in data memory. Okay?
Hmm. Okay.
Yeah. So all these are shifted operands and all. Very important, okay? Multiplication interaction instruction and multiply and accumulate, very very important. Why is it so? Why is it so? Why this mac units are very important?
Simultaneously, it has to perform two operations.
Correct, very good. That is from the speed up point of view. And why is it important in our daily life? See, most of the digital signal processing operation that we do, they are all mac based. Okay, convolution, you are just multiplying and then adding the, just hold on. family বলে পাওয়া যাবে না। Yeah. So yeah. So yes, it is mostly used for, see, you do any kind of thing. Okay, let's say convolution. Okay, convolution is what you multiply two variables and then you add. You keep adding. You keep adding. You keep adding. So normally when the convolution, let's say it's the number of elements are very high or number of samples are very high, you have to do repeated number of addition and uh, multiplication operation, right? To in order, because Mac units were not a part for older microcontrollers. Okay, for the new microcontrollers, especially for the ARM and all, so it came into picture. The only reason was so as to speed up the whole thing. Right now, you can see that this multiplication and addition both are happening in one cycle, right? Hello.
Yes, sir.
Yeah. So both are happening at one cycle. So this is very important for all the signal processing algorithms. Okay. And for your machine learning also. In machine learning, it is very, very important because you multiply the inputs with weights, okay? Then you add them up and then you pass it through activation function. So when you multiply the inputs with weight and then you keep adding, then at that time these Mac units are very, very important. I mean, it is always preferable to use a controller which has got the Mac units for DSP or for ML kind of algorithms, okay?
So when you say Mac units, you mean to say hardware?
Yeah, Mac units means this MLA, this R1, R2, R3, R4, this is multiply accumulate instruction, right? So this
Yeah,
is,
but this is a software based, but we can have another hardware
yes,
just
but
for doing multiplying.
correct, but you have to see, these are on instructions, right? But who is giving the instruction? The controller will give instruction to the Mac unit to perform this, right?
Hmm.
So this R1, R2, R3, R4, you have to give it to the Mac unit, but you have to also tell the Mac unit to perform this operation, right? One is the data giving,
Okay.
another is the control. So everything is done by one instruction. So this is essentially giving the Mac unit an instruction that yes, you have R1, R2, and sorry, R2, R3, and R4. You do the operation and give the result back in R1. Okay. So this is a specialized
Hmm.
instruction for all the Mac units. Okay. Similarly, we have data transfer operations. Okay. So so you have this data transfer operation is mostly on this memory to register, okay, or from register to memory. So they use register indirect. What is the meaning of register indirect? Register indirect means the memory in which you want to write, the memory address in which you want to write, that memory address value is stored in some register. So here right now, if you see that R1 is holding the memory address in which you want to write the value of R0, okay, or I mean, for the store. So for the load, what happens is the memory address which is stored in this register R1, you fetch the value from that memory address and put in R0. Okay. So here I am not explicitly specifying any memory address. The memory address is stored in R1. Okay. So that's why it is called registered indirect addressing. Okay. So you get everything. For example, you cannot see, you may see some offset, but you will never see a proper memory address in this instructions. Okay. Now you have something called, I think sir has covered or what? I don't know. Sir has covered or not. Okay. So I think it is there in 8085, okay, where you can do registered direct addressing. Okay. So
Hmm. Yes.
yeah. So but in ARM it is only registered indirect addressing. Okay. So first you fill up the R1 with some value, let's say 2020, and then the moment you do a load instruction, what it means is it takes the value from the memory location 2020 and brings to R0. Okay. So with this you can do many things. So LDR and STR, these are the basic instruction for which, I mean, of this register indirect addressing. Another instruction is ADRL R1 table. Okay, it's again very, very important. When you bring a set of, I mean, if you see this R1, how it is initialized, how to put a value in R1. So you first put the memory value in R1 through this instruction ADRL. Okay, that in that way R1 will hold the memory address. Okay, so because then for this LDR and STR to work, you have to make sure that R1 is uh, given the memory value with this ADRL instruction. So first is this instruction, and then you have these two instructions, okay, for any exchange. So in the later part, whenever you see this LDR, STR, it automatically follows that you have already uh, executed this instruction. Okay, then only R1 writing R1 like this will be valid. Okay, so this is multiple. So these are basically, so for your exam purpose, I would say whatever is covered in the slides, okay, that you read very well. This LDRB, STRB. Do not go to ARM datasheet. Okay, ARM instruction datasheet don't go. You will not be able to, figure out, because there are too many instructions, and the way they are written, uh, you need some practice or you need some experience. I mean, if you keep reading all those data sheets, it will be okay for you in this short span of time. For example, if you have not seen an ARM data sheet, then suddenly just before the day of exam, it will be very, very tough. So um, just make sure that you study all these instructions. Okay, for example, if you are confused about all this instructions, just try to search in net. It will be very, very, because ARM has got very good knowledge base in the internet. So that way it is very, very good. Okay. Mm, then you have this. Someone is coming now. Okay. Hmm. Hmm. So another important part is this auto increment R9. I think this exclamation. I think you can expect some question from this auto increment. Okay, auto increment is very important. I do not know auto increment is support is sir has given. Yeah, I think you should learn about this. Uh, what to do data transfer. Let me check. This
Sir, page 18.
page 18. Huh? Hmm.
Yeah, 1-8.
Page 18 of which, lecture 1 or lecture 2?
This lecture only.
Achha,
Week 2 PDF, page 18.
okay. Oh wait, I think I have gone somewhere else. No, it is not there here.
Auto indexing. So
Ah,
this
correct.
auto
Auto
indexing third
indexing.
one.
Yes, 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 yes. Not. So this is very important. Okay. So just make sure to see this R1 automatically increments after R1 equals to R1 plus 4. Okay. So this is the way it auto increments, and it's very important in this kind of architecture. Okay. So this is primarily one of the reason that you can do a DMA transfer. Okay, it auto increments always. Okay, so just keep this auto incrementing is very important. Just think on those, and then
Yes, sir, here a small doctor.
hmm.
And these instructions.
Sorry.
Thumb instructions, sir.
Thumb instructions. Okay, see, thumb instruction are 8-bit instructions. Okay, so normally ARM has got 32-bit instruction. Okay, so ARM thumb has got some 16-bit instructions and 8-bit instructions. But what is important for you is, so ARM has got the capability to switch between normal instruction and thumb instruction. Okay, so just by setting the thumb bit of the, I think one register is there. So in ARM, so but by setting that bit, you can switch between the uh, 32-bit instruction and
The
8-bit
C,
instruction. CPCR, I think
yeah, the C,
CPSR, CPSR,
CPSR.
yeah,
Yes.
CPSR.
CPSR, yes. So yeah, so you can do that, and it's right because see what happened is when ARM started with thumb instructions. Okay, it was reduced size, but then eventually as the number of instruction increased, it moved to 32-bit instructions. But then what happened? People still use some old thumb instructions. Okay, so it was very difficult to make the ARM compatible for both. So that's why they have introduced this register with the thumb bit, so that they can switch between the instruction anytime. So right now you can combine some of the thumb related C coding with your normal 32-bit C coding. Previously what used to happen is you have to make a separate file where you make this 8-bit, sorry, the thumb bit C coding, and a separate file where you can do is 32-bit C coding. Okay. So that is not required now. So that is the use of this thumb bit. Okay.
Both cases, what is the immediate value size, sir? Is it only 8-bit value, sir? Uh, here immediate hash
Immediate means?
hash 4 or something is there, sir. R2 plus 4 or something. So that 4 will be the.
Immediate data.
Correct, correct. Acha, okay, okay.
Then I am asking what is the size? Is it 8-bit only? Even it is a 32-bit the general ARM instruction. Then also, what will be the size of
No,
the
I think this one is 8-bit only.
8-bit? Okay,
Yeah.
sir.
Yeah, because see, the whole point of, see, in 8085 what used to happen is you have this instruction in one memory, then you have the data operands in other memory, right, in the subsequent memory. But here in ARM you have everything in 32-bit. Okay, so you have to make sure that, I mean, all the data fits there. So hmm. I think that is all from this instruction. I don't think, I mean, just understand, I mean, whatever instructions are covered in the slides, you must understand that really well. Okay. For example, the loop instruction. Okay. So
One
this
more.
BNE, this compare is just a data processing instruction because it is operating on both the registers. But BNE, okay, branch if not equal, you loop. Okay, so this is changing the sequence of the program counter, because program counter is supposed to go to the next location, right? But then it will, instead of going to the next location, program counter will go to loop, it will go to previous, and it will keep looping. So that's why it is said as this branch, BNE, for jump, these are all control flow instructions. It changes the control of the, it changes the flow of the program counter. Okay, yeah, tell me.
Lastly, about the pin diagram, sir. Same material, sir. Go to the
Hmm.
last slide, sir.
Last slide.
After,
uh,
after the
in
board. Next.
next, this one. Okay,
Sir, pin diagram like Arduino pins and STM board pins will be there, no, sir. Pin,
here, this one.
sir.
Tell me.
Just give a glance that um, about the PWM pins. We have a doubt, sir.
Hmm.
Actually, how many digital pins are there?
How many digital pins are there?
Analog pins and
Hmm?
how many PWM pins?
I think, no, see, PWM pins, if you're there, it is already there, right? PWM 1, 2, and PWM 2, 4. This one.
So just we are setting the.
Acha, this is in Nucleo, right? This is Nucleo. In Arduino, it is different.
I am asking you only nuclear, sir. Nuclear.
Acha, Nucleo. Okay, okay. Yeah.
We are setting the uh, writing the statement in the software or the program itself. We make that as a PWM pin, sir.
Exactly, exactly. Yes, yes, yes. Because it is multiplex with this pin, no? SPI select. It is multiplexed. This pin will either perform as, PWM pin or an SPI select pin.
So how much difference is there between? Now you see, sir, here it is an analog one, A not. A
Hmm.
not an analog one.
Hmm.
We use the same pin as a digital pin also, sir. Is there any restriction?
I think yes, you can use, because there is a multiplexer inside. So you can use. So for example, right now this A0 pin, if you see, this
Yes.
A0 pin is used for UART CTS, which is a digital pin, a PWM, which is a digital pin, but it's also used as ADC10, right?
Okay, sir.
Yeah. So it can be multiplex. It is possible to multiplex. Because see, if you see a digital pin is nothing but a 5 volt, right?
Yes, sir.
So yeah.
So the pins appearing in these headers
Hmm.
are directly connected to the pins of microcontroller,
Yes,
isn't it?
absolutely. Yes, and that's why you have whatever you see in on this side, boot 0 and CNC. These are the pins of the microcontroller, and this, I mean, this is what you can configure to. Okay. Okay. Anything else?
Sir, the touch sensor is based on the digital input, no?
Touch sensor is based on. I think it is what.
Digital input.
Yeah.
Yeah, so in the experiment, why it is connected to the analog pin?
Just hold on. Can you tell me the PDF? Let me see.
I guess it's week 7 or 8. I have to see.
Just hold on. Using touch sensor, right? This one.
That's it.
Let me see. Let me see. Okay. No,
Yeah,
it's
in the
a.
experiment, the
Hmm. Just hold on. Ah, this is a capacitive element variation, no? So it is analog. Just hold on. Yeah, right on. Hmm. Correct. It is analog, no? It is
no, it should be
analog.
digital because the definition is also given as
Where the definition is given? In this one, TP223B. This one.
In next paragraph, sir.
Next
Next
paragraph.
paragraph, second next.
Oh, acha. It is given like this, huh? I don't think so. Okay. I think there is a mistake here. I think there is a mistake here. If you search 223B, let's see, huh? 223B and what it does. Hmm. No, the slide is correct. It gives out an analog input, okay, analog output, okay. So why it is connected to a A0 pin? So well, you can connect it to a digital pin also. So what you can do, see what they have done is if the touch value is greater than 1000, so it effectively makes it an digital comparing output, right? So right now, if you see what is the range of the digital input that you can analog input that you can get, what is the bit size of ADC?
10 bit.
10 bit, right? So it is how much? 1024, correct?
Yeah.
Yeah. So that is the maximum you can get. So that's what it is saying, that when let's say the digital output it is giving, let's say 5 volts. So your digital input, if you take it as an analog input, then the value should be more than, I mean, that will be very close to 1024, right? Because your input, that pin will give out 5 volts. Okay. So if that pin gives out 5 volts, then you can, I mean, what you are saying, why it is given to analog pin, you can also give it to a digital pin and make it work. Okay. You can make work. I mean, you can put into a digital pin and make it work. That's for sure. Because it gives out. I just saw the data sheet. It gives out only normally high, and that to V minus zero point 0.8 power supply. Yeah. So put pin current. So it is like more than 2.4 volt and less than zero point 0.6 volts. So yes. You can work with that. You can configure it with a digital pin also. That is for sure. Hello. Hello, who had asked this question?
Actually, I lost my connection.
Okay, okay, yeah. So yes, you can configure it as digital also, because it gives out digital.
Okay.
But then all the digital values, see, for example, if you are taking only a plus and minus, then you can give it to a analog pin, and then you can measure the voltage of the digital pin, right? So that's what they are doing in this program. Okay, but you can do it with digital pin also. That is for sure. But
Oh.
but but the point is, but there is a catch here. For example, let's say you change the touch sensor. Okay, you change the touch sensor, and right now you are using a touch sensor such that the output value is not 3.3 or 5 volt. The output value is always either 2.5 or 0. If you do that, then
Hmm.
this kind of coding will be very very helpful, because you have to just change the threshold, right? Because if you
Right.
configure it, if you configure it for a digital pin, it might give a 0 for 2.5, because the high voltage is set at 2.4. It is very near to that. So it might sometimes give 1,
Hmm.
sometimes it give it might be jittery. But for example, if you give to analog pin and read the digital voltage, you just have to configure this number, right? 1000. So that way, I think, I mean, that's why that is the reason they might have done with analog read. But then intuitively everyone would first use a digital pin, and with that
Yes,
digital.
actually, I did the experiment using digital one.
Correct, 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 correct. So that is okay, but try out with analog also, because this will give you the flexibility to connect different kind of touch sensor.
Hmm. Okay. Thank you.
Hmm. Okay. Okay. Anything? So I guess all the best. When is your exam tomorrow?
Afternoon.
Morning.
Afternoon. Okay. Okay. Chalo, all the best then, and just keep doing embedded systems. I mean, the more you do, the more you
For
see.
me, it is forenoon.
For you, it is.
Forenoon.
Acha,
Morning.
forenoon.
Morning
Okay,
For
okay,
time.
me
forenoon.
also
Okay,
morning.
okay, okay, okay. Forenoon. Okay. Yeah. That's okay. Whatever be the exam does not matter. Okay. I mean, just study well, because what is more important is if you continue with the embedded systems. That is more important, because there are many things to learn. Just cover this course, just gives you a very gentle push. Okay, and it covers less than 0.001% that is currently there. So there are many other things, many other things. Okay, and the more you read about controllers, the more you will understand the capabilities. So keep working on projects. I mean, I would suggest to not to use a nucleo board, but maybe use some other STM board. You have used now, I think some Arduino board. Use some STM board, use a TI board. Okay, used ESP32. So all these controllers are there. Just try using them, because then only you can, for your project or for your.
Are there any NPTEL course on this ESP32, ESP8266 like that?
No, I have no idea. No, no.
It's on Udemy actually.
It's a new demi maybe. Yeah. But what is more important is you have to keep. I mean, embedded system is less of what is there in the book and more of what is there in the hardware. So I mean, keep practicing, because there are many other things which is not covered here. You have not covered boot code. Okay, you have. Can anyone tell me what is watchdog timer?
Um, if there is some issue with the functioning of the microcontroller, the watchdog timer sets in,
Hmm.
indicating there is a problem.
No, watchdog timer
I
never does.
guess.
I understood. I understood. That is a good try. That is a good try. But see, watchdog timer is, it is like, let's say that you are studying. Okay, let's say you are
Hmm.
studying, and my job is to just pinch you every 1 hour. Okay, so that even if you sleep in between while studying, because of my pinch, it will wake you up. Okay, so let's say
Hmm.
in
Hmm.
C code, let's say you have written one while loop. Okay, and that while loop,
Hmm.
it is stuck somewhere. Okay, it is, the program is not coming out of the while loop, it is continuously there. So this program, so this watchdog timer, it will make sure that it resets the microcontroller. The work of the watchdog timer is to reset the microcontroller. Okay,
Okay.
so you have to write a code so that the microcontroller, let's say every 20 millisecond, every 30 millisecond, resets the watchdog timer. Because if you do not reset the watchdog timer will reset you. Okay, so there are
Right.
many interesting concepts like this in the microcontroller. The more you study about it, and in fact, more than studying what you should do, you should buy 2 3 microcontroller and study what is there inside. Okay, and try to configure it.
I
So
actually have started using ESP32.
hmm, hmm.
I'm doing it under the Arduino software, but
Correct,
I
correct.
guess we have to program it using MicroPython, I guess.
Yeah, but see, the problem with Arduino software, which I don't like, is too many things are abstracted. I mean, things are very easy because you just call functions and it happens. But you should actually
Right.
look into the register level details. Okay, which bit to set, where, what to do, exactly in what sequence you have to
Uh,
write. So all these things are very important. So I would suggest try out a small TI microcontroller, maybe TM4C 123G, that microcontroller, and then try to configure the registers. It's very important.
so
Once you do for
so
one microcontroller, it is same for almost all the others. But you will get a very good
so you're
feeling.
talking about bare metal programming.
Absolutely, bare metal. See, Arduino is also bare metal programming. Okay, Arduino is not RTOS based. Arduino is also bare metal programming, but it is library based programming. I mean, you are just
So
calling the libraries. Okay,
okay, right.
that way. So all the best. I'm sure. I mean, all of you will give effort and try to do more of this project, embedded system project later on in your life. Okay,
Hmm.
it will be very
Thank you,
fun.
sir.
Okay, okay. Just take care. Okay, bye bye.
Thank
So
you.
one more
Thank you.
thing I wanted to ask you, sir,
Sure.
about your experience at IISc. Like, how was it? And
Top class. I see, like, I was in HL. Okay, I was in
okay,
HL. So I already had the experience of all those Air Force going to from Ministry of Defense and all. Already had those experience. Then working with
okay,
fighter aircrafts and helicopters. So that was a very good experience. Okay, it was very dynamic, very dynamic, and
okay,
it will always keep you on your edge. But then when I came to ISC, okay, I left my job and then came to ISC. So for my masters, but then I converted to PhD. So it is
okay.
more calm here. Okay, like it is very peaceful and calm here. So if you want to, I mean, improve yourself as a person, I think you should definitely visit ISC once. It is very calm. I mean, I mean, you will never know that you are in Bangalore. In Bangalore, the nightlife and Mumbai nightlife, I think they are very good. But then in ISC, will never feel all these things. So
Mm.
I think, yeah, and everyone is allowed to visit. Okay, so you are in Bangalore, Ankita.
Yes, sir. I'm feeling Bangalore.
Then yes, then please do visit.
Actually, my few friends are doing internship in a startup there, sir. So
Mm-hmm.
I've been listening to them. Even they're like they're not interested in college at all. They're like full ISC will be there. Full day we'll sit there. We'll do internship. So
Yeah.
it,
So ISC
uh,
is like that only. I mean, so you must visit once.
yes,
And
sir.
I
I must.
and I'm in this DESE department. So this DESE
Okay.
department is also at that at the far end. So it is also very, it is calmer even. Okay. So that
Okay.
way.
So it's like a town in itself.
Yeah,
I feel.
yeah, it is a town because you have all the greeneries, you have mini forest, you have gardens,
Uh,
and then you have supermarket. So all those
okay.
things. The only thing that you don't have here is cinema hall.
Uh,
So, but
you won't
here,
need that, no, sir.
yeah, but in lab,
uh,
what we do is we have big
uh,
projectors, so
uh,
we put in cinema here, and we all, everyone watches. I mean, the lab members.
oh,
So that way we do. So we have fun in our own way, and
yeah.
there is occasionally DJ, then fest.
Oh.
DJ is very
Recently
good.
there was some fest, I
Yeah,
feel.
yeah.
Uh,
Mm. So all this fun is there. So once you come to ISC, it will be difficult for you to move outside. So
uh,
that way, the people are very good. They're very, I mean, approachable. You can go to any professor and talk. Okay. So and
hmm.
even if they say that they don't have time, they will say in a very polite way. So
uh,
so that way. ISC is like that. Chalo, you must visit once. Everyone here.
Yes, sir.
And whoever is there. Yeah. So take care and do well. Okay.
Thank you,
Maybe
sir.
yeah. Maybe if I am the TA of any other course, then maybe we'll meet and if you guys are taking. So yeah.
Okay, sir. Thank you, sir.
No problem.
Thank you, sir.
Thank you. Thank you. Bye bye. Bye bye.
Thank you, sir.
Bye bye.
Mm.
Thank you.